Hi guys, this is Semih Boaz and I'm gonna talk about OpenCV. OpenCV is an open source computer vision and machine learning software library, and CV stands for computer vision. OpenCV is written in natively C++ and has a templated interface that works seamlessly with standard template library containers. Officially launched in 1999, the OpenCV project was initially an Intel research initiative to advance CPU-intensive applications. Part of a series of projects, including real-time ray tracing and 3D displaying walls. The main contributors to the project included a number of optimization experts in Intel Russia, as well as Intel Performance Library team. In the early days of OpenCV, the goal of the project were optimized code for basic infrastructure, more readable and transferable code, and advanced vision-based commercial application. So what kind of problem does it solve? The library has more than 2,500 optimized algorithms that can be used to detect and recognize faces, identify objects, classify human actions in video, track moving objects, extract 3D models of objects, produce 3D point clouds from stereo cameras, stitch images together to produce a high-resolution image of an entire scene, and so on. To support some of the areas, OpenCV includes a statistical machine learning library that contains boosting, decision tree learning, gradient boosting trees, expectation maximization algorithm, k-nearest neighbor algorithm, naive Bayes classifier, artificial neural networks, random forest, support vector machine, deep neural networks. What are the prerequisites? Basic programming knowledge will be enough if you're just going to use OpenCV as a helper in your project. But developing some new things about detection, recognition, or robotics will require the knowledge of Viola-Jones algorithm, Haar-like features, integral picture, classifier training, adaptive boosting, cascading, image processing, and statistic, and so on. OpenCV can run on Windows, Linux, Android, and Mac. It has a C++, Python, Java, and MATLAB interfaces. To start developing some things, first we need to set up the development environment. To do that, let's install Python with Anaconda, which is a free and open source distribution that aims to facilitate package management, and PyCharm IDE for faster coding. Write Anaconda Python and click the first link. I will download it for Windows, but you can find a lot of resources for other operations. Click on download button for version 3.7 and select a place to download. After the download process finished, standard installation step can be tracked, and select add Python to my path while processing installation for Anaconda. With installation of Anaconda Python, we also install OpenCV and other necessary libraries. Now, let's see some examples about face and eye detection using OpenCV. Open PyCharm. I will show it for a video footage, but you can do that using webcam or on a picture. Before jumping into coding, you must download Cascade XML files. These files include ready-to-use trained models. You can find the files on OpenCV's GitHub page. Here I have 13 seconds video, and the video must be audio free. To do that, go to Audio Remover website. Now let's begin coding. Write import CV2 to use OpenCV libraries and image I/O to make processing on images. Define two objects, one for eye and one for face detection from Cascade Classifier class, and give XML files as parameters to this class. Let's define our function for recognitions, named detect. It should have an image as parameters. Call it frame. In our function, we will detect faces and after that, find eyes in faces instead of scanning all over the images for faster detection. Cascades detects faces in black and white pictures, so we must change our pictures with CVT color function of CV2 library and give our frames and what to do as parameter. When we find the face or eye and put a rectangle around them, we need to take its coordinates x and y for left upper corner, w for width, h for height. There can be more than one face in pictures, so we keep them in a variable named faces. Face detection occurs with detect multiscale function of Cascade Classifier class. Let's call this function and give parameters like our gray pictures, scale factor as 1.3, and if there is a real face, at least 5 neighbors rectangle must detect it. Now write a for loop. This loop will iterate for every face inside faces variable. We can draw rectangle with OpenCV's rectangle function and give picture its coordinate and the color for rectangle and thickness value. To detect eyes in faces, we need to define two fields for both gray image and colorful image. Iterate inside gray image faces with coordinate y to y plus h and x to x plus w. Same operations for colorful image. We take the necessary area. Now we can detect eyes. Write gray face instead of gray, 1.1 for scale and 3 for neighbor rectangles. To detect multiple eyes in a face, we need to define another for loop. Do same operations like we did for drawing face rectangles on gray images. Finally, write return frame to complete the function. Let's create an object with getReader function of image.io library for ease our operations on images, and give our audio-free video name to open. Now take FPS value for dividing video into images with getMetadata. After detection, we need to show our results in a new video named output with the same FPS as original video. So we are done with defining. Now let's write a for loop that will detect faces with eye to show frame numbers. Inside for loop, apply detect function to frame that we took from the video, and append all the images that include rectangles into and output video. Write print eye for tracking frame numbers. Outside of the loop, we need to close our writer video. Now we can run the program and see our results. Training has finished, and let's look at the output video. As a conclusion, you can see our algorithm is not very successful to detect every face and eye in the video, because objects are very small for it. If you try this with webcam or a bigger picture, detection will occur successfully, or you may try object detection models. So, this was a brief video about OpenCV and how to use it. Thanks for watching.